This video is going to be on factoring the sum and difference of perfect cubes. And before we actually talk about factoring them, let's make sure we understand what the perfect cubes are. So if I was looking at this and I was talking about perfect cubes, some examples of them, basically you take each of your whole number values and you would cube it, or raise it to the third power. So if I had 1 and I raised it to the third power, that would give me 1. And if I had 2 to the third power, right, what's that? Well, it's 2 times 2 times 2, so 2 to the third power, that'll give you 8. If I had 3 to the third power, so 3 times 3 times 3, that's 27. You could continue like this. If I had 4 to the third power, 4 times 4 is 16, times another 4 is 64. You could always use your calculator to raise it to these exponents. 5 to the third power, just taking a look at a few more. 5 to the third would be 5 times 5 times 5, which is 125. And 6 to the third power, that would be 6 times 6 times 6, which would be 216. And you could continue like this forever, right? You could keep, raising each whole number value to the third power, and you'll get out a value. These values that we're getting, right? So this right side here, this whole set here, these are the perfect cubes. Now you could do this forever, but being able to identify the perfect cubes is really the most important part, because that's going to help us know when we're able to factor using the sum and difference of perfect cubes. So recognizing this series 1, 8, 27, 64, 125, 216, all the numbers that fall in here will be especially important. If you're not sure if a number is a perfect cube, you could use your calculator. If your calculator is one that displays everything on the screen, a lot of times you might see this as a second key on your exponent button, but it might look like this with the little x root. You want to put the root of 3 for cube root, and then the value you want to evaluate. So if I want to evaluate 216, the cube root of 216, this should equal 6 when you try it on your calculator. Now remember, 216 is the perfect cube. 6 is the number that we cubed to get there. If your calculator doesn't display everything on the screen, you might have to type this in backwards. You might have to type in 216, then hit the button, then hit the root, and then it'll give you 6 out. You'll have to practice that on your own because everyone has different calculators. So for a value to be a perfect cube, right, it's a number times itself 3 times. For a variable, right, so let's put a little note here, because these are for the numerical values, but for variables. So note, for a variable to be a perfect cube, meaning something times itself 3 times gives it to you. For a variable to be a perfect cube, the power must be divisible by 3. If you remember when we talked about something being a perfect square for a variable, we said the exponent had to be even, meaning divisible by 2. So to be a perfect cube, it has to be divisible by 3. And this kind of applies to any other perfect powers, right? A perfect fourth power would be power divisible by 4, and so on. So for perfect cube, we're looking for exponents that are divisible by 3. That's how we know the variable is a perfect cube. Let's talk about now our special factoring formulas that come from here. So when we factor, we're going to talk about factoring the sum or difference of perfect cubes. And I'll write these separately just so you can see them. But if I said the sum of perfect cubes. Okay, so the sum of perfect cubes. And I look at this here. We're saying things that have the form of sum, meaning addition, and a perfect cube. So something cubed, I'll call this a to the third power, plus, because it's a sum, something else, raised to the third power. So I'll call it b to the third power. So a and b are just dummy variables here. They're placeholders for our formula. And the way you would look at this, right, if I have a cubed plus b cubed, the way this factors, I'm just going to talk about it, something you're going to need to memorize. But the first factor you would need is, whatever the base was here before it being cubed. So we want a, and then this is plus, so it stays plus, and then b. So it's the first factor. And the next factor, we kind of build off that. Well, if I'm multiplying two things together, I need to get a cubed. Then a times what would give me a cubed? Well, this is an exponent of 1. You're going to need 2 more to get to 3. So a times a squared will come first. All right, so it's whatever the first thing is squared. And then this was plus. You're always going to use the opposite sign next. So I'm going to put minus here. And then for the middle, you just multiply the bases together. So minus, this will be AB. And then the last term here is going to be 3 terms. The last term here in this factor is going to be plus. It's always plus. And then we had b here. We're trying to get to b cubed. So what do I need? Well, I need b times b squared. And we're going to close that off. So, this is something you'll need to memorize for the sum of perfect cubes. So if your two things are being added together, perfect cubes, you can factor that by taking, the first factor being the base plus the base in parentheses there, right? So that's still the plus because that's plus. So you keep the first sign, put an S here for same. And then you had a, so you need a squared to make that a total of 3. And then this minus is the opposite sign of this. So the first sign stays the same. The next sign becomes the opposite. The middle is just the bases multiplied together. And the last sign is always positive. So I'll say AP, so always positive, always plus. And then the last term is always whatever the last base was squared. So you had to multiply the b times the b squared to get your b to the third. So kind of the way people remember this is SOAP, right? It spells SOAP. The same sign, opposite, and always positive. And then you just have to remember what the terms are. I'll show why this comes out to this in a second. Let's talk about just the difference of perfect cubes, and then I'll explain why the formula is what it is. So the difference of perfect cubes, which is very similar in terms of the formula. Right, the difference of perfect cubes, we'll have, I'll just call this a to the third minus b to the third. All right, and we're going to follow the same type of format we did above. So the first factor, all right, is going to be a, the base. Now since it's minus, remember it stays the same, so it's minus, right? That's what our SOAP tells us to do. So minus stays minus, and then that's b. And then the next factor will have 3 terms. We had a cubed, we had a, so we need to get a squared to multiply a squared times a to give me a to the third. So remember, we're undoing multiplication when we're factoring. So minus was the same. Now we need the opposite, so we need this to be plus. We multiply the bases together here, so this is AB. And then the last term, remember we said it's always positive or always plus, so we put a plus there, and then we had b to the third. You factor out b, we're going to need a b squared. So, this is how you factor things that are in the form of the sum of perfect cubes or difference of perfect cubes. But the key thing is that these both have to be perfect cubes. These both have to be perfect cubes to use this formula. So, this is something you should memorize. We're going to show some examples using it in a second. You should understand how to use the formula and where it comes from. But remember, the signs are same as the original, opposite, and always positive. A lot of times people can remember the terms, but they don't remember the signs. So it spells SOAP. That's the easiest way to remember it. I'll show why this comes out the way it does here on the side, just so you understand where it's coming from. Let's talk about what would happen if I was just looking at this first formula, and I actually multiplied these together. So I'm going to distribute through. If I had a plus b times a squared minus ab plus b squared, when you go to multiply this out, how do you multiply it? Well, you multiply, each term from the first thing to the second. It's kind of like FOIL, but you have 3 terms, so you're distributing through everything. So a times a squared would give me a to the third. A times a negative ab gives me a minus a squared b, right? Because a times a gives me a squared, and the b just comes along. A times b squared gives me a positive a b squared, and that's me multiplying a through everything. Then I'm going to multiply b through every term in the second. So b times a squared, well, that's the same as saying, positive times a positive is positive. A squared times b is just a squared b. So I'm going to write this underneath here. You could write it in a straight line. I'm going to write it underneath just so you can see it. So plus a squared b. B times negative ab, a positive times a negative makes this negative. ab times b is ab squared. And then the last term here, positive b times positive b squared is a plus b to the third. So then you want to simplify this. Simplifying this, taking a look, what do you have? Well, you have a cubed stays a cubed. Combining like terms, negative a squared b plus a squared b, they cancel out. positive ab squared minus ab squared, they're like terms, they'll cancel out, and you have a cubed plus b cubed, so it checks out, so that's how it factors. So sometimes people wonder why that ab falls in the center like that, and it really has to do with, it ends up canceling in the middle. So if you have something that's the sum of perfect cubes, right, it'll factor to this. If we use this and foiled this out, or distributed this out, and we got this difference here, you would see it works out. I'm not going to show it. But understanding that these are the formulas you should know, the sum and difference of perfect cubes. And you only can use it if you have things of that form. So let's take a look at a few examples. So the first example here, if I was talking about, if I just said, remember the directions will be factor. And we're going to factor x to the third power minus 125. Now, when you go to factor, you should still be thinking the same type of process in your head every time. So the first thing you should look at is how many terms do we have? Or actually, the first thing you should look at is this our greatest common factor? And in this case, we don't have a greatest common factor. There's no GCF other than 1. The second thing you should look at is how many terms you have. And in this case, we have 2 terms. If you have 2 terms, that's what's telling you to look to see if it's either the sum or difference of perfect cubes or the difference of perfect squares. First off, is this the difference of perfect squares? Well, it's not, because, you know, the third power isn't divisible by 2, so you know right away it's not the difference of perfect squares. 125 is also not a perfect square. The other thing that you should check, right, so sum or difference of perfect cubes, well, it's not a sum, right, there's no plus here, so you don't have to worry about that. So right here we've got a minus sign, so it's a difference. Are x to the third and 125 perfect cubes? Well, x to the third is a perfect cube because really that's x being raised to the third power. The power is divisible by 3. Remember that little note I put on the previous page. Right, a variable is a perfect cube if the power is divisible by 3. In other words, I can write this as x to the third power, just as a little placeholder. Is 125 a perfect cube? Well, if we go back to our previous page, right, here's our list of perfect cubes. Yeah, 125 is a perfect cube. What number is it? It's 5 to the third power. So I'm going to write this as 5 to the third. So we got x to the third minus 5 to the third. Remember, this is really like when we were talking about a and b. A was whatever was being raised to the third power here in our formula, so that was a. 5 here is being raised to the third power. That's b. So when I use my formula, looking at this previous page just a second, first off we're looking at the difference formula. So we're looking at this one down here. My a in this case, right, what I was just talking about, right, is going to be the x. B in this case is going to be the 5. It's what's being raised to the third power. And then we're going to use the formula to fill in for a and b. So, right, we know the formula. Maybe I'll write it up here just so you see it. A to the third minus b to the third. Right, that's equal to a. Remember, the sign stays the same, so we have minus, and then b. And then the second set of parentheses, we have a. We need to be 3 total, so we need a squared. This is going to be the opposite of the first sign, so this will be plus ab. You multiply the bases together. And the last term, remember, is always positive, so we have a plus here. And then it needs to be b squared. So this is the general formula that we're using. We're substituting in for it right now. So what are we substituting in? Well, a is x and b is 5. So we're just substituting into here. So we would have, all right, a minus b would be x minus 5 times in parentheses a squared. Well, a is x, so it would be x squared plus, all right, so same, opposite. And then multiplying the bases together, a times b is x times 5, which is 5x, but I'm going to write it as x times 5 just so you can see how I'm substituting into the formula. We'll rearrange that in a second. And then plus, last term's always positive, b squared, well, b is 5, so it'll be plus 5 squared. Now we're going to simplify this, but we're following from this formula. So what does this give us? Well, when I factor this, state x minus 5, this is x squared plus x times 5 is going to be 5x, and then plus 5 squared will be plus 25. And then we factored it. So we factored that difference of perfect cubes. Okay, so we used our formula from the previous page, and we noticed right at the very beginning that we had the difference of perfect cubes. If you don't have that, you can't use this formula. Everything has to be a perfect cube in there in order to use the sum or difference of perfect cubes formula. So you've got to make sure that all the pieces are perfect cubes. Let's take a look at another one here. If I said to factor And let's say I gave you, let's say p to the third power plus 27 q to the third power. Right, so the first thing you should be looking at here is, okay, is there a greatest common factor I can factor out? And in this case, there isn't other than 1. Right, so p cubed and 27q cubed don't have anything in common other than 1. Next thing you should do is count the number of terms, and I see 2 terms here. When I see 2 terms, that leads me to think it's either the difference of perfect squares or the sum or difference of perfect cubes. Well, first off, the plus sign tells me it's a sum, so we know it's not the difference of perfect squares, so we don't have to worry about that. The sum or difference of perfect cubes, well, we know it's not a difference, so is this the sum of perfect cubes? It's a sum because there's a plus sign. And now remember, everything in here has to be a perfect cube for this to be the sum of perfect cubes. Is p to the third power a perfect cube? Well, yes, because the power is divisible by 3. Is 27 a perfect cube? Well, did it fall on our list? Yeah, 27 was 3 to the third power, so 27 is a perfect cube. And is q to the third power a perfect cube? The answer is yes, because it's raised to the third power. Remember, if these weren't divisible by 3 in the exponent, they wouldn't be perfect cubes, and we wouldn't be able to use this formula. So p to the third power is really, I could write it as p to the third power, as a base to the third power, plus the 27q to the third. I want to write that all as one base raised to the third power. Well, 27 we said was 3 to the third, q to the third is just q to the third. So we're going to write that as 3q, that whole quantity to the third power. Sometimes people leave that 3 out. You need it to be in there. So what you're really looking at here is your a is what we called p, and your b is the 3q. So let's use our formula. So our formula says, I'm not going to write the whole thing out, let's see if we can remember it. So factoring the first part is always, right, the same sign you're going to use, just use the basis. So usually it's going to be a plus b, so in this case a is p, so it's p plus b, which is 3q. That's our first factor. And then remember, our next factor has the 3 terms in it, and remember you start with, okay, I had the first base to the first power, I need to get 3 total, so this is going to be p squared, because normally it's a squared, right? So p squared. Alright, now remember the signs. It's the same to start with, then it's the opposite, so this will be minus, and then we do the bases a times b, so in this case it's p times 3q, and I'll write it like that. We can simplify that in a minute. And the last sign is always positive, or always plus, so you have a plus there. Remember, that's our SOAP, same, opposite, always positive. And then we want b squared at the end. B squared is going to be 3q, the quantity squared. Make sure you square the whole thing, not just the q. It's the 3 and the q getting squared there. So then to simplify this, we keep it factored, p plus 3q. And then inside here we have p squared minus, this is p times 3q, which would be 3pq. Plus here 3q squared, the 3 gets squared, which gives us 9q to the second power, still q to the second power, so 9q to the second power. And that's how it factors. Occasionally this could factor in very special cases at the end, but usually you'll be done here. You should be checking this trinomial at the end if you suspect that it could factor based on ways we use in other videos. But in this case, that won't factor. Most of the time it won't. Let's try another one. If I said to factor this one here, 64x to the third minus 27y to the sixth. So you may want to pause this and try it for yourself and then watch the video after and make sure you have the correct answer. But let's take a look. First thing to look at here, is there a GCF you can factor out? And you want to be careful here. 64 and 27 don't have a greatest common factor other than 1, so there's no GCF there. X and Y are different types of variables, so you can't factor anything out there. The next thing you want to do, count the terms. The number of terms we have in this case, we have 2 terms. 2 terms tells us either the difference of perfect squares or the sum or difference of perfect cubes. Now, is this a difference of perfect squares? Well, it's a difference. It's got subtraction there. Is everything in here a perfect square though? Well, no. 64 is a perfect square, but x to the third is not. So as soon as you see that x to the third is not, and the reason we know that is the power isn't divisible by 2 evenly, you can say it's not the difference of perfect squares. Also, 27 is not a perfect square. Why the sixth is, but 27 isn't. So as long as one part isn't, then you can't use difference of squares. Is this the sum or difference of perfect cubes? Well, it's not a sum, right? It doesn't have a plus sign, so we don't have to worry about that. Is it the difference of perfect cubes? We got a minus. Is 64 a perfect cube? Now, if you're not sure, you can take the cube root of 64 on your calculator and see if that comes out evenly. You could also refer back to our list. Is 64 a perfect cube? It is, right? That's 4 to the third power. Some of the numbers you see won't be on our list, though, so you want to make sure you check those on your own. So we know 64 would be 4 to the third power. X to the third power, that's a perfect cube because 3 is divisible by 3, so it's 4x. And that whole quantity is what's raised to the third power, so it makes it a perfect cube. We have minus here. And then is 27 a perfect cube? Well, it is, because 27 is what number to the third power? Well, it's 3 to the third power. So we know we have 3 in there. Is y to the sixth a perfect cube? Well, remember, for a variable to be a perfect cube, right, the power must be divisible by 3. Is the power divisible by 3 here? Well, 6 is divisible by 3 gives you 2, so we know y to the second is what we have in here. And then the power on the outside of all this is 3, which makes it a perfect cube. So you've got y to the second here, because 6 divided by 3 gives you y to the 2. So for the exponents, you're basically dividing them by 3, and that's what's going to go on the inside of here. And you have a 3 on the outside, which is what you need. So once you have this, all right, now we see it's the difference of perfect cubes, which is great. We're going to use our formula. And let's make sure when we use our formula, we're going to do it from memory, but we can refer back to it if we need to. Remember, A is whatever's inside of here being cubed. B is whatever's inside of here being cubed. So the first part of our formula, remember, we use A and B, and then whatever sign we had stays the same. So we have A, which was 4x, minus B, which in this case is 3y squared. Make sure you have parentheses around it. You need it, because when you factor, remember, that's showing multiplication. And then in the second set of parentheses, remember how it works. You want a squared, because you start with a, so you need a squared. Well, what's a squared? Well, a squared is the 4x, that whole quantity squared. Make sure you write it that way. So it's 4x quantity squared, and we'll simplify that in a minute. Remember the signs, it starts with the same, and use the opposite, so we started with the subtraction, so now we need a plus. So plus, and then we want a times b. Well, a times b in this case is 4x times 3y squared. That's why it's important to label this here so you know what you're using. So it's a times b. So we have the same, opposite, the last sign always positive, or always plus, so plus, and then we want b squared. Remember, b was the 3y squared, so we really want 3y squared, the quantity squared. And then once you have this, remember what we're doing. We're just going to simplify. So the 4x minus 3y squared will stay as is. Inside of here, 4x quantity squared will give me 16x squared. 4 gets squared gives you 16. X squared gives you x squared. Be careful. A lot of people leave off that coefficient. If you don't put these parentheses around it, you'll only square the x and not the 4. Plus 4x times 3y squared. You can multiply the 4 times 3 as the coefficients. Gives you 12. X times y squared. You just write it as xy squared. And then we've got plus, here I got 3y squared, the quantity squared. So the 3 gets squared to give you 9. The y to the second power, when you have a power to power, remember you multiply the exponents. This would be y to the 4th. And close that off. And then you factored it. Alright, and then let's just take a look at one more here. If I said to factor and we had 5x to the third plus 40y to the 6th. And you might want to pause this for yourself just to make sure you understand how to do it. But if we go through this, first thing I look for when I'm factoring is a greatest common factor. Make sure you're thinking that to yourself. It doesn't happen every time, right? We haven't even seen it yet in these videos today. But if there's a greatest common factor, you should factor it out. In this case, is there a GCF? Well, there is. The greatest common factor here, between 5 and 40, we have a GCF, which is equal to 5. So you have to factor out 5 first. Don't try to do two things at once. Don't try to do factoring the 5 and the cubes. You want to take the 5 out and then Remember, when you factor it out, you're really just dividing each term and then writing what's left. So 5x to the third, factoring out 5, would leave me with x to the third, plus 40y to the sixth, factoring out the 5, would give me 8y to the sixth. Close that off. Now, once you factor out a GCF, remember how it works. Typically, the GCF, the greatest common factor, stays in front. And then you'll work on factoring what's left in the parentheses. Now we go back to what we did before. We want to count our terms. Well, how many terms do we have here? We have 2. We have 2 terms. You should be checking, is it the sum or difference of perfect cubes or the difference of perfect squares? In this case, it's not a difference, so we know it's not the difference of squares or the difference of cubes. So is this the sum of perfect cubes? Well, we got to check to make sure all the pieces in here are perfect cubes. So x to the third, well, yeah, that's a perfect cube because 3 is divisible by 3. It's really x to the 1, or just x raised to the third power. 8y to the sixth, is that a perfect cube? Well, 8, is that a perfect cube? What number times itself 3 times gives you 8? Well, that's 2. Right? 2 to the third will give you an 8. Y to the sixth, is that a perfect cube? Well, 6 divided by 3, that's 2, so we have y squared. Remember, this whole thing you want to be able to write as a perfect cube. So when I talk about this, A is x, and B is the 2y squared. It's what we did in the problem above. Just making sure you understand where it's coming from. So once you have that, now we're going to factor this right here as the sum of cubes, because we've just shown that these are perfect cubes. It's a sum, so there's a plus there. So when you factor this, remember how it factors. The first set of parentheses is just A, keep the sign the same, and B. So A plus B in this case would be x plus B, which is 2y squared. Remember, it's what's on the inside here. Don't bring the cube with it. Close that parenthesis. And the next set of parentheses, remember that you start with a squared, because we used a already. So you need a squared. A squared in this case would be x squared. And then you use the opposite of the first sign used. So same opposite would be a minus sign. And then a times b would be, in this case, x times 2y squared. I'm writing it like this, just so you can see how it simplifies. If you can see that quicker, you could write it quicker. So x times 2y squared, this is a times b. And then the last term, remember, always positive in that second factor, so always positive. And then it's b squared. B is 2y squared, the quantity squared. Make sure you have parentheses around that squared because the 2 in front also is getting squared. And now we're just ready to simplify. So GCF stays in front. Remember, you need that as part of your answer. You can't just drop it. So GCF in front always stays in front. First factor of x plus 2y squared stays there. The second factor, x squared, stays x squared. Negative x times 2y squared will be negative 2xy squared. Plus, remember, the 2 gets squared here, and the y to the second power gets squared. So 2 squared will give me 4. Y squared squared, power to a power, you multiply the exponents. 2 times 2 gives me y to the 4th. And then this is our factored form. So, you know, this is our final answer here. And we did something a little different in this problem compared to the previous ones, which was we actually had to factor out a GCF first. Make sure that you're paying attention to that. If you don't factor out a greatest common factor at the very beginning, it's very likely that it'll be buried somewhere in here if you could factor it even to that point. Since 5 wasn't a perfect cube and 40 wasn't, you wouldn't even have been able to get to this perfect cube factoring yet. So you had to watch out for that kind of thing. So, you know, you might want to try a few more of these on your own. But, you know, this is really how you have to go about factoring something that's the sum or difference of cubes. So remember, first step is always looking for a GCF. The second thing that you should be looking for is number of terms. 2 terms either tells you the difference of perfect squares, which was in our previous video, or the sum or difference of perfect cubes, which was in this video. If it's neither of those cases, then, you know, you can't use either of those formulas. So hopefully this video helps.